Welcome to lesson 3 of Intro to Swift Protocol with Bob the Developer. In this lesson, you will learn how to group all kinds of objects into an array or anything without using typecasting. Well, let's learn about that in this lesson. Alright guys, welcome to Protocol as Type with Bob the Developer. Here's a problem statement. No more typecasting. Back in the days, I mentioned that typecasting is not the best way to go about when it comes to grouping objects and organizing into a small batch. Alright? Like for example, in the past we've probably done something like this. Let's not use Bob. I don't know why. Just when you're learning something, Bob is such a generic example. It comes every textbook. Bob, Amy. I guess I just use Bob as a default. Anyway, so back in the days, in order to group things, you learn how to do, one becomes any. These are structs. They're being upcasted, right? And this array is also being upcast to any, right? Automatically. You don't have to use any because it's automatically being upcasted by itself. Okay, so if you were to, so this provides some sort of a grouping together, and you find it, oh, this is nice too. It's a very handy feature to use it. But in fact, if you were to go back to use number 1, you have to downcast it, and you have to use unwrapping, if else, or force downcast. It's really painful in the butt. So you don't want to do that. In fact, there's a better way. When it comes to protocol, it solves that problem. Protocol as type. Let's talk about it. So what is type in the first place? If you remember correctly, type is nothing more than just, if you go back, your string is actually type, right? Nothing more than these are just structs and enums and classes. Those are type. We call the type the name of something for classes and struct. That's type. That's what type means. Okay. So protocol can also be the type. Well, for example, you can have Bob, Humanable, something like that. Do you think it's possible that the protocol becomes like a type of it? Well, let's find out how to do that. So let's design a protocol called East Asianable. And I believe a lot of East Asians use chopstick, right? I've growing up using use both nowadays. But, still I use chopstick because right now I'm in Korea taking a year off from college. So I use chopsticks. And then the origin, let's say from China, Japan, Taiwan, Hong Kong. Those are East Asian countries, right? Anyway, I just wanted to use this example. So now let's extend this protocol and provide default implementation for chopsticks. So let's try to do that. Use chopsticks. This extension East Asianable var use chopsticks. And can we do store property? True. Can we do that? Again, by the way, you remember correctly, get. If you're using store property, it doesn't matter whether it's get or set. For computer property, if it's get, you can make it gettable and settable. But if it gets set, you have to make it settable. But it's complaining for extension. You may not have store properties. I guess that's part of the rule when you're working with extension, not just protocol. When you're extending, you're not allowed to have default store value. You have to use computer property. I don't really exactly know why that's the case. I wish I knew, but I just couldn't find the answer. Maybe it's going to be implemented later down the road. Okay, so here we go. We have chopstick, use chopsticks. Every struct classes enums that confirms the East Asianable should have use chopstick property available. Okay, so let's create some blueprints for that. So you have Korean, East Asianable. Our origin is Korean, Korea, Republic of Korea, not from South. Korean is actually, when we say Korean, refers to South Korea these days. I guess that's when you see somebody from, say, Korean, probably they're from South Korea, okay? Because in North Korea, you're not allowed to escape from that country unless you're working for the government, okay? So when I say Korean, that means I'm from the South, and most of you guys will notice that they are from the South. So if they look like me, then they're from the South. Well, doesn't really make sense, but most of them are from the South. So now what happens is, how can you group things together? Well, can we group things together? Well, you can. How is it possible? Well, let's find out. In fact, you can do something like this. East Asians and you're able to say, hey, the type of this thing is East Asianable, okay? And then you have Korean, Japanese, and Chinese out there. How is this impossible? As mentioned above, protocol can be a type. So just like string, just like string, just like int, protocol is actually type, okay? Anything that confirms a protocol can be a type. And you have the Korean, Japanese, Chinese. These are objects that confirms to the East Asianable. You're able to do that. So you don't have to use typecasting, go back and forward, doing this nonsense. You probably will never do something like this unless you're working with database. When you're getting data, for example, JSON file, you probably use any with dictionary. But beyond that, when it comes to UI kit, you probably should ever avoid typecasting. Okay, but of course you're gonna use protocol and programming instead of that. So now here's the magic. What you can do is you have the ability to use, let's say, use foreign lib, East Asian and East Asians, and you have the ability to use that method origin right there. How is this possible? Well, it is possible because you know that East Asian, every East Asian, this Korean, Japanese, it all confirms to East Asianable. And if you remember correctly, East Asianable contained these two properties, use chopsticks and origin. So this is very, very neat way to organize and get the value or properties of run functions of each one of these. Very nice and neat. Can you imagine with typecasting? You probably have to typecast if you remember correctly from the previous lessons, we have to use as, if it's UI color, UI view, apply it. If it's UI label, apply it. If it's UI, there's a lot of, a lot of repetition going on. But here in this case, you don't have to repeat because you know that as long as it confirms to East Asianable, it contains this origin property available for you. Okay, so how can it be useful? With a practical example with UI, well, you are able to combine UI label, UI view, and loop through them, and change color, animation, and so on and so forth. So all you have to do is, hey, just create extension. I'm just going to show you an example. UI image. I think we have to import UI kit. Okay, so you create a protocol, and then you create a defined protocol. Okay, and then all you have to do is extension. Your extension UI image, okay, image view, and then let it confirms to the protocol you defined. For example, you can say protocol unique, just call unique view. Doesn't really matter. You can say unique view and the unique view right there. Okay, so as long as now you have and you can do extension UI label, unique view, and then you're able to combine them together because they all confirms the unique view, or you can eventually use it as something like extension as UI view confirms the unique view, and then everything else that comes along, such as UI view, UI image, UI label, UI button, they all confirms to unique view. But of course, I'm not going to talk about it in this course. Yeah, I'm not going to talk about it. Well, if you want to know more, again, I've attached an article in the previous lesson about protocol programming with UI kit, right? Learning how to animate. I'll talk about protocol. You can be used as type there. So go back if you want to learn more about it. Okay. But in this lesson, I'm going to talk about the fundamentals of Swift, and all you have to do is understand the fundamentals, how it becomes easier. So I'm going to talk about protocol. This is the last part, protocol med generics, right? Generics is amazing for providing a scalable code without having to write a lot. But protocol also provides scalability, but let's learn how two things can work together. So I'm going to design a protocol called Sleekable. When it comes, Sleekable means like a diamond, those like bling blings, amazing, like sleek, like a steel. So, there's a price to it, let's say. So let's make a diamond that confirms to Sleekable. So we have a struct that confirms to Sleekable. The price is very high. Okay. I'm gonna make another two structs and classes doesn't matter whether you're making a class or struct, doesn't matter, because you know that as long as it confirms to Slickable, there's a property called price up there. Okay, so we have diamond that confirms Slickable, Ruby Slickable, all good. Okay, so now what you want to do, you want to create a function, and that function is only allow you to work with Slickable. How do you do about that? Well, first of all, let's learn how to create generic protocol, a generic function. So in the past, you learned how to do that. Let's say state the price. In order to work with generic protocol, you have to make a placeholder type called T, or you can call it whatever, right? The convention is to use T, enter gem. And what you want to do is, you want to do something like this. Hey, I'm expensive. In fact, I am enter.price. But it's not working. Why is that so? Because the T is not defined yet. T can be string, T can be what? T can be int, T can be human, T can be Bob, doesn't really matter. Because when it comes to generic code, you can just simply add anything. But in this case, you want to have enter gem and also want to have price property. How do you go about that? Well, simply you can define that. You can restrict, have a constraint that you can only work with Slickable right here, right? Remember generic constraint back in the days? So now, because T confirms to Slickable, now the Swift is able to guess, because T confirms to Slickable, it must have a property called price up there. Okay? That's pretty nice, isn't it? It's amazing. It's pretty good. So now you're able to run this function, and you can only enter something that confirms to Slickable. So Glass now confirms to Slickable. You can enter Diamond if you want to. You can enter Ruby if you want to. And that's it. That's how you apply protocol along with generics. So hopefully, again, I hope you understand why we use protocol in programming. But just try to think about how you can do it with typecasting. Do you think you can do it with as question mark, as exclamation mark? Probably not going to be able to do that this easily, but protocol does provide this kind of ability to do that. Again, if you want to learn about practical example, go to the article and learn how to animate stuff without having to use typecasting. Okay, well, all I wanted to make sure to talk about is, remember, protocol can be used as a type, and as long as the type, it provides default implementation, so you're able to use something like foreign lib to have East Asian.origin. It's a very amazing feature. So when people come to learn Swift from any other programming languages, such as JavaScript, they come from Ruby, they come from, or even in Java, they come to Swift and they say, wow, this thing provides really amazing features. Protocol is amazing. It doesn't really, other languages, they some have something like protocol like called interface, but most does not provide this powerful feature as in Swift. So, use this as much as you can. And throughout this, in the next course, hopefully I can give you as many practical examples. But in this course, the focus is to understand why. And hopefully if the purpose has been met, and I'm okay with that. And you guys can find how on your own. And see you guys in the next lesson. And bye-bye. Boom. You've learned how to combine all kinds of objects, from classes to structs, into a single array without having to use typecasting. It works because protocol can be used as a type. We're going to apply this magic in the next lesson to learn how two objects may communicate with each other. Well, see you in the next lesson.